as we talked about yesterday, the chart at the bottom should have helped you organize the problem that we came across with the variables a little bit, about the cases versus the actual numbers of jars and numbers of candy bars, okay? So it says that we're trying to raise money for homecoming. We're going to do this fundraiser. We want to sell candy bars, and we want to sell these jar candles, okay? And then we order them in cases, and we're going to make the best informed decision that we can about how many we should order of each, assuming that we can sell all of each to make the most profit, okay? So all the information about the cost of each, how much money we make off of each, all of that stuff was given up above. And then it defined the variables for us, like we talked about you would have to do, because when we built the constraints without defining the variables yesterday, then we had one that was based on number of candy bars and one that was based on like cases of candy bars. So we had to be a little bit careful about that. So notice the first line of the chart helps us determine the number of cases, okay? And it told you above that X was going to represent the number of cases of chocolate bars, and Y was going to represent the jars of popcorn. Sorry, I said jars of candles, but we're selling jars of popcorn. So sorry. Messed up my fundraisers. Okay, so then this was the problem we came across, and this should help us organize it. The number of units versus the number of the number of cases. So the number of units is each one individually. So if X is the number of cases of Hershey's bar we are ordering, what is the number of units for the bars? 30X. Because 30 bars come in a case, right? So if I order that many cases, I'm really getting this many bars. Okay? All right, what about the jars of popcorn? 10Y, because when I order a case, I'm getting 10 jars of popcorn. Okay? All right, the cost to order each. So cost is what I'm paying out. Profit is then later what I would sell them for. So remember, X is cases, and the cost is given per case. So we just want to write that cost in terms of X, how much for each case. Okay? So $10 for a case of candy bars. Okay? How much for a case of the jars of popcorn? Alex? So it costs us $5. $20, right? So this is how much we're paying. So 20Y for our jars of popcorn. So we're paying $20 a case for those jars. Now the last line is the profit. This is what we can sell them for. Now remember, if we're still going to include X and Y, this is representing a case. So the number that you're pairing with this needs to be the number or the amount of profit you're going to make for a case of the candy bars, not for each candy bar. Good. So somebody explain to me why it's not 1X if we're selling the candy bars for $1. Why is it 30X instead?
Because 30 chocolate bars in a case, and you're selling each one for $1.
Good. Okay, so we are selling each one for $1. So the dollar is the amount. But remember, these variables represented cases, and there was 30 chocolate bars in the case. Yes?
For our profit, wouldn't we instead take away the amount that we're paying for it?
Well, the amount that we're going to pay for it is going to show up on our graph as what we can and cannot buy. So it's going to restrict the area that way, and then we're going to test each thing that we come up with from the graph in this profit equation. So it's already going to have taken into consideration the constraints on what we're paying.
No, I mean like for profit, like wouldn't, because it's $10 case.
I understand what you're saying, but we paid a certain amount of money for it. But so you're going to see in the business model you're given that you're going to be given a certain amount of money to spend at the beginning on what you want to make. You're going to spend that amount on what you're going to make no matter what. We just have to spend less than or equal to $500. We've already set that in our parameters at the beginning of the problem. So we're already prepared in our account to spend $500 on the fundraiser, no matter what. Okay, we're going to spend less than or equal to $500. Okay. Then the goal is, what are we getting out? So even if we're spending $500, we just want to look at the most that we get out independent of what it was before, because we already know we're spending that $500. So at the end, when I look at the numbers, those numbers might not include the fact that I spent $500 at the beginning, but whichever one is more is still going to be more. All of them would have to have the $500 at the beginning that I'm taking away from them. Okay? Because we're not looking at We're not going to look at individual profit when we plug it in, because at the end, you're spending the same amount at the beginning. You're always spending $500. So you're going to buy all the supplies for $500 no matter what. Then you're trying to see just what you can make once all the supplies are here. Okay? So it doesn't matter. I know what you're saying, but it doesn't matter about that $1 right now, the way that we're viewing it as a whole, because we're spending that initial money no matter what. We're going to see what's going to make us the most. Yes, that initial money would have to get subtracted from your books when you show how much you made off the fundraiser. But this is going to calculate how much money is going to be in your pocket at the end of the fundraiser, despite what was spent at the beginning. Does that make sense? Okay. All right, so then what about the popcorn jars? Yeah. So 50, good. Okay. And again, even though we're selling them for $5 a jar, okay, it's about the fact that 10 jars are coming in the case, and because we were using X and Y to represent cases, we couldn't just put the individual dollar amount next to these variables. We had to put the amount we would earn on each case in total. Okay. All right, now the total columns. Okay. So what this is saying, the number of cases I order in total, if I'm ordering X cases of this and Y cases of that, this is going to be X plus Y. And that's how we're going to calculate our totals in each case. All right. So the number of units I'm ordering in total is going to be 30 candy bars for each case of those, plus 10 jars of popcorn for each case of those. The cost is going to be $10 for each case of candy bars and $20 for each case of jars of candles. And the profit, okay, but like we talked about before, we're not including that initial amount that we're spending, because we're just putting a different constraint on that for the total, that we're looking at 30x plus 50y. Okay? Now, all of these things, okay, all of these things have constraints on them that we're going to take into consideration and find first, and at the end we're going to try to maximize our profit. This says right here that this is profit. This is going to be part of our objective function. So this is going to be part, this is going to be our objective function and what we're trying to maximize because of its profit, right? So there's not a constraint on this. This is what we're using at the end to make the most money that we can, okay? The constraints are going to lie on these things here. Now, did they give our constraints, like some of these overlap? Like, do we want to use number of cases or number of units for our constraint? So if you look back at the problem, when they put a limit on how much you could order, did they put the limit on the number of units or the number of cases that you could order? The number of units, okay? And what was the limitation? Okay, so the number of units is 400 maximum. Okay, what was the other constraint they gave you about the fundraiser? Yes. $500 was the maximum you could spend at the beginning on your supplies. So this is $500 maximum. Okay. So then this comes down to where we can write these restrictions or these constraints. And remember, it should be a system of inequalities that tells us, like, everything's going to happen, but it has to happen in these ways. Okay, like you can't order more than 400 of these. You can't spend more than $500. So what that's going to look like, can somebody give me one inequality that represents one of our restrictions? Yeah, Dana? Good. 10x plus 20y is less than or equal to $500. Okay? And that's coming from right here, okay? From the cost that we wrote an expression for it, and we knew that it had a limitation. Okay, Alex? And 30x plus 10y is less than or equal to 400 is coming here from our restriction on the number of units that we're allowed to order. Okay? Good. Okay, and we also are going to include these two functions. Can somebody, I know he understands why they're up here, or else he wouldn't have thought of how to put them up here. So can someone else explain to me why he would include these in his restraints? Allison?
Because you can't have like
trying to sell a certain amount of items, we've already determined we're doing the fundraiser and we're selling stuff. Well, it's not going to be a negative number of candy bars or a negative number of jars of candles. So we're going to concentrate on first quadrant only because we're looking at positive values for each of them. Okay? All right, now what about our objective function? What is that going to look like? The thing that we're trying to maximize in this case, or in other cases, maybe the thing you're trying to minimize. How are we going to calculate that? What will that function look like? Ideas? What is it that you're trying to maximize? Profit. Okay, so, okay, or you could use like the notation that we talked about yesterday, okay, that you wrote down in your notes. And how is that profit being calculated? Any new people that haven't answered a question yet for me today? Look at the chart. How are we calculating our profit? Yes. Good. Okay. Right here, our profit, $30 for each of these and $50 for each of these. So 30x plus 50y. Remember, that's a little different than what you're used to because it's not plug in an x value and get out a y value. It's plug in how many of the x's and how many of the y's to find out how many dollars in total will be coming in at the end of the fundraiser. Yes. Yes, it is okay that if instead of profit, you labeled that with P or an F of x comma y. Okay? That is math notation that you guys would see. Okay? Any questions on anything here setting this up? All right. So it is okay for you guys to go through and divide everything by 10. But then do keep in mind when you're graphing things and stuff like that, that you did divide everything in 10 in case it affects like your results, right? Okay. So when we look at this, notice I only have the first quadrant up on my screen. And the reason for that is because of these two constraints and the idea that we aren't going to sell a negative number of a certain type of object. Okay? So I already know that the y-axis is acting as a constraint, and I'm only going to look to the right of that, and that the x-axis is acting as a constraint, and I'm only going to look above that. Okay? So I already know that. Then the question is, where are these other boundary lines that are kind of limiting how many I could choose of each project or of each product to sell? So I'm going to use these other two lines in order to create that. So for the first one, if you want to graph it in slope-intercept form, okay, then you should be able to transform that inequality to slope-intercept form by subtracting 30x to the other side and then dividing everything by 10 if that's how you want to graph it. And when you're done with that, it should look like y is less than or equal to negative 3x plus 40. Now, to graph that, you need a y-intercept of 40 on the y-axis, okay, and then you're going to use a slope of negative 3. Now, what did y represent for us in our problem? Yeah. I subtracted 30x to the other side and then divided everything by 10. Okay. All right, so what does y represent for us in our problem? Yeah, Sean? Okay, good. So the cases of popcorn. So this axis is representing the cases of popcorn. And then my x-axis is representing the cases of candy bars. Okay? I'm just going to write it out here. All right, so I have my two axes. I know I labeled mine off to the side, but I want you to be able to see the numbers I put on there also. You have better space, so you can label appropriately on yours. All right, so how do you guys want to label our x-axis or our y-axis? What do you guys want to count by? We need a slope or a y-intercept of 40 and a slope of negative 3. Twos? Okay, so then if we number by twos, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Okay. That fits pretty well. Okay, so I'm going to put my y-intercept there at 40. and then I'm going to use my slope of 3. Now, I also need to have my x-axis labeled. Okay. What do you guys want to label the x-axis by? By 3s? Do we need to label the x, like, are we going to need as much? What's the maximum maybe x value that we might need? You think we need 50? Okay, so you want to label it by 3s? Okay. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Just marking some random ones for reference here. And I should mark 30 instead of 27. 33, 36, 39, 42, 45, 48, and then 51. Okay. So there's our x-axis. Okay, so for our slope here, that makes it a little bit difficult if we label our x-axis by 3s, because we want our slope to go down 3 and over 1. We got to be careful of our scale here. When I jump a line here, I've gone down 2, but when I jump a line here, I've gone over 3. So be really careful with your slope. It all depends on how you labeled something. Okay? So I don't want to just go down 3 and over 1, because then I've really gone down 6 and over 3. Mm-hmm. Okay, so here, the x and y intercepts, if we choose to use that instead, so the x-intercept for this problem, if we plug 0 in for y, the x-intercept is going to equal 400 divided by 3. So somebody who has their calculator out, what are we getting here? 13.3? Okay. So, all right, so 13.3, so we're only like right over here, right? Sorry, 30. Thank you. Sorry. Yeah, okay. 3, 6, 9, 12. So 13.3 is like right there. All right, so you can graph then the line that's going through 40 and down through that x-intercept. Okay, so I'm going to go ahead and do that. I'm going to use a line tool to help me because I can't draw straight lines on here. All right, so there's our line. Now, are we shading above or below that line that's dividing our graph? Below. Okay, how do we know that? Somebody besides Eric or Matt. Yeah.
Does anything past that line exceeds our constraints?
Good. We are looking for y values that are less than this boundary line. Okay. If we took y values outside of this, that would be above a specific y value on the line. So we're stuck inside this little triangle of area. Okay. All right. Then when we look at the next line, so I'll graph that one in a different color. Okay. So when we look at the second line, okay, if we go about the method of graphing the x and y intercepts again, if you plugged 0 in for y in the second equation, what would be the x-intercept? Eric, I know you know. I need some other people to show me that they know. Yeah, Claire? Good. So the x-intercept is going to be 50, and this is part of the reason Eric made the decision about scaling the graph in a way that we would reach 50. Okay? So the x-intercept is going to be 50. Didn't want blue. I'm going to mark my x-intercept at 50. What is the y-intercept going to be in this equation? Cody? Don't trip. Monet? 2? Well, we have 20y and we have 500, and then we would have to divide both of them by 20. So how many times is 20 going to go into 500? Huh? 25. So our y-intercept here is going to be 20, 22, 24, 25. Okay. And then I'm going to draw the line that goes through those 2 points. Okay. So we have our line that goes through those 2 points. What is my feasible region? Where am I really looking in this problem? Alex? Good. Inside the quadrilateral. So we're really focusing on looking at this region inside of here. Okay. Now, what that means is that we could choose for our fundraiser, okay, any values that are in here. And what I mean by that is, let's say this point right here. What does that point represent me selling in this fundraiser? Helen? Nope, this point that I made right here. Good. So this would represent me making a decision to sell 3 cases of candy bars and 10 cases of the popcorn jars. Okay? That would be fine, and I would make some amount of money. However, to maximize the amount of money, we want to look at the most extreme cases. We want to push the boundaries to their limit. So the extremes are the vertices of this quadrilateral that we're looking at. So those are the most extreme situations in this scenario. Okay? So any point in there is something you could do within your constraints, but the points along the edges, those vertex points, okay, are the extremities. They're what we're focusing on. So one vertex point is 0, 0. So you guys have a place to list these in the next section. Okay, so one vertex point is 0, 0. Okay. What was this vertex point up here? Right here. Maybe? Good. 0, 25. If you lost track before and you didn't know, now I know it's not that hard to tell that that's 25 because we numbered by 2s, but you just have to remember which line that was that you were graphing, and it was the y-intercept of that line, and you'd have to go look for the y-intercept of that line, and these are things that you learned how to do in Algebra 1, and if you're struggling with them, you just need to make sure you're coming into tutorial to figure that out. Okay. What about this point down here? Okay. What is that point, Matt? So it's 13.3, 0. And again, if you're like, how did he know that was 13.3? Well, he's not guessing. He would go back to the fact that it was when we were graphing this first line, and it's the x-intercept of that first line. And you'd have to go do the algebra with the equation to give you the exact value of that x-intercept with that line. Now, here's our 4th point right here. Okay. Ideas on what that point is. Allison? So 6, 22. Okay. So 622. Now, this was really nice because it was off the graph. When you guys are doing your project, you're going to make up some of the constraints on your business. Do you think that somebody randomly made up these numbers and they just worked out so nicely on the graph for you? This is like a gift, right? Whoever made this problem gave you a gift. They're crossing right there for you to see, okay? You saw when we looked at the real life data, when we were looking at that exercise data stuff and trying to plot our line, most of the time was your line crossing through these beautiful little coordinates also nicely on the graph. No, it was hard for you guys to figure out your equation because you had to first estimate the points where it was crossing at. So my question to you is, what if this didn't work out so nicely? Because in your project, it might not work out so nicely once you lay all these things on the graph. How would you figure out the exact coordinates of this point? So we've already talked about if they're on an axis, you can figure out an x-intercept or a y-intercept of an equation, whether it's nice or not so nice, by doing the arithmetic in the equation to figure out the x or y-intercept. What do you do to figure out where 2 lines cross if you can't clearly see it on the graph? Good. You use the 2 equations and you try to find x or y by using substitution or elimination. So a little review in case anybody was struggling. I know that you don't need to do it in this case, but this is meant to help you in case you come across a more difficult scenario when you're doing your project. Now notice I changed the inequality to an equal sign because I'm not focused right now on where the shading is or where the solutions are. I'm focused on where these 2 exact equations cross at that point. Okay? And so then here, 10x plus 20y equals 500. So using substitution or elimination, you're either going to solve one of them for one of their variables and plug it into the other equation. Or if they're written nicely in standard form like this and you can immediately see something that if you multiplied by a nice number, you could get it to cancel, you could do that. So if I multiplied, say, everything here by -2, okay, my focus being that it's going to make that equal to -20y. And that's going to cancel nicely with the positive 20y I have in the other equation when I combine the two lines together. But I can't forget that I would then have to distribute that to each term in that equation. Okay. So those two would cancel when I added these together. I'd end up with -50x equals -300. And so then x would be equal to 6. Not surprising in this case, we could see that from our graph. And it should at least still match what your graph is saying. But if it didn't turn out to be exactly 6, if it was like 6.3 or something like that, that method would tell me exactly what it was, okay, if I was uncertain. And then I could just plug 6 into one of the equations above. And then I could finish solving this equation for y. So this is a little bit of Algebra 1 review. So that if you come across this situation and you can't find the points where they cross, you have a chance at kind of figuring that out. Okay? Do we remember doing this in Algebra 1? Okay. All right, so that's how we would use that smaller application in this sense. Okay, now the whole purpose of me doing this, I found what I could do with my fundraiser, but I'm trying to optimize my profit, so I'm looking at these most extreme cases. So we want to take these 4 vertices and look at what the profit's going to be in each situation. Okay? So now we're going to take each of those vertices and compare them to that objective function, that profit equation that you built. So we already talked about the fact, I know you can't see mine that well, but our functions were 0, 0, or our vertices. And then we had the y-intercept that was at 0, 25. Yeah. And then we had the x-intercept down below that was at 13.30. And then we had the vertex that wasn't on an axis that was at 622. Okay, you guys have those listed from the picture that we just made. So to evaluate our profit at each vertex, what we're going to want to do is think about each vertex. And what they look like in our profit function. And remember, that was, somebody remind me of what our profit function was. Helen? So what we want to do is plug the x and y values in and see what's going to bring in the most money at the end of the fundraiser. So obviously 0, 0, which is why the lady called it trivial in the video. What happens when we plug in 0, 0? If you're not selling anything, you're not going to make anything, okay? And our profit is being measured in dollars, okay? All right, what about if we plug in 0.25? Somebody let me know what you get when you do that. Matt? Can somebody confirm that he's correct? Yeah? Okay. All right, what about when we plug in 13.3, 0? Tina? 399? We have confirmation that that's correct? Yes? All right, what about when we plug in 622? Eric? Okay, so you see all the extreme situations or the possible extreme situations based on what they look like graphically and how they actually turn out. What would you pick to do for your fundraiser if your goal is to make the maximum amount of money? Helen? Good. So we would choose this situation here because it's giving us the most. And this should now make more clear the conversation we were having at the beginning about the profit equation, that the graph took into consideration that we were spending up to $500, okay? And so all of these, we would subtract whatever amount we were spending from them, okay? But this one's going to end up being the most because it's the maximum out there.
Like, what if the 0.25 was the same? You still can't take this into, right, because you're actually selling.
Good. Okay, good question. So what if the 0.25 was the same? So that actually comes into a question I feel like doesn't have a clear yes or no answer, but as long as you had justification, it would be fine. So you could say, if these both worked out to be the same, Like, no, we're going to sell 6 of one and 22 of the other because we want to offer both products during our fundraiser, okay? Or in this situation, if you were trying to start a business, it would probably be a better decision, I don't know, but to offer multiple products because then you have different types to sell, you know? If it's a one-time fundraiser, you might argue, if they came out to be exactly the same, it might just be easier for you to order this amount of cases from the one company, okay, and just sell that one thing, okay? Eric? Yeah. So we would adjust it at the end. But all the constraints have taken that into consideration by giving you the most extreme values. Okay? But you're right. Does that make sense to everybody, how you're picking your final answer? Okay? All right, so then the final thing says, what is the maximum profit and when will it occur? So you have the answer here and it just kind of wants it in that sentence format that you're explaining to somebody. Okay, so the maximum profit here is $1,280. And that would occur by selling, okay, or by ordering, you could say it either way, 6 cases of candy bars and 22 cases of jars of popcorn.